Hola, 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 hola. Ok, vamos a hablar uh, of the trigonometric functions. We're going to talk about their graphs. So remember, this is a general form of a trigonometric sine or a cosine. And for all of them, we have parameters that can modify the behavior of the function. Before we go into the parameters, let's review the pattern graphs for cosine and sine. Remember, these graphs are just the result of unwrapping the unit circle into a straight line. So let's identify the pattern graph of sine. So we know that sine has a period of 2 pi, that is, as a full circle, that is 2 pi, is where we can find all the possible values that sine can attain. And those are the values we can see here between these two red lines. So, what happens with the values of sine? We know that sine is 0 in, when we evaluate it in 0, when we evaluate it in pi, and when we evaluate it in 2 pi. In other words, if we see this as a graph, we know that the function sine intercepts the axis or the midline, in the extremes and in the middle of its period. So, if between the red lines, the section between the red lines, it's my period, the sine graph is gonna intercept the midline in the extremes of the period and halfway through the period. Now, the sine, we know that is sine of pi halves is 1, and sine of 3 pi halves is minus 1. That is, in other words, that sine has its maximum in the first fourth, that is, if I divide my period in four parts, in my first fourth, my sine attains its maximum, and in the third fourth, my sine attains its minimum. Okay, so this is the pattern graph. In general, we have this behavior. Inside its period, the function sine is going to have its intercepts in the extremes of the period and in the middle, and its maximum is in the first fourth, and its minimum is in the third fourth. For the cosine, we're going to have a similar behavior. Here I have my function cosine, and its period is determined by these blue lines. That is, between these two blue lines, we can have all the possible values of cosine. Notice how these functions slightly change. This is a big lump, while cosine in its period has two lumps, okay? So we were going back with cosine. So cosine is going to obtain its maximums in the extreme of my period. It's going to have its minimum value, que is minus 1, in the middle of its period, and in the first and third fourth of my period, I'm going to have the x-intercepts, okay? Remember, when I'm talking about the maximum and minimum value of cosine and sine, just think about the evaluations in the unit circle. What is the highest value or the maximum value the sine or the cosine can have in the unit circle? Well, the answer is 1 or minus 1. So those are the maximum or minimum values of sine and cosine, okay? So these are my pattern graphs. I'm going to put them together. So 2 lumps for sine, 1 big lump for cosine, and notice that where the sine has its x-intercepts is where the cosine has values, the maximum and the minimums, and where sine has the maximum and the minimums, cosine has the x-intercepts, okay? So they are like complementary to each other in that aspect. Now, if we go back to the general form of sine and cosine, what we're going to see is concepts that we are already familiar with. That is, if we have a constant multiplying the function, we know that that constant is going to affect the amplitude of my function. That is, it's going to stretch it out vertically. We know that if we have this constant adding or subtracting to the argument, that is an horizontal translation. or displacement, and in trigonometry we call it a phase shift. And lastly, we know that if we have a constant adding or subtracting at the very end, that is going to be a vertical displacement, just as we did last semester, okay? And the same parameters happens in cosine. And we can use all this information in the pattern graphs to graph trigonometric functions, the basic ones. Sines, bueno, all of them, but we're just going to work with sines and cosines. Okay, so this is another important thing. We know that sines and cosines are periodical. That is, this is just an abstract of what they look like, but we know they look like this. They repeat themselves infinitely to the infinity. So if I want to start graphing, obviously I'm not going to graph all of them. I just have to graph a cycle. That is, a cycle is where I can find all the possible values of sine and cosine. That is, what I have to graph is a period. All the possible values in a period of a cosine or a sine. So to do that, I have to select an initial point from which I'm going to start graphing all my function. And that initial point is just going to be the point determined by the phase shift and the vertical translation. Okay, so the initial point is the phase shift, comma, the vertical translation. So let's do some examples. Here I have this example. So first let's identify all the parameters. So the first parameter A, its value is 3. The second parameter B is 1/2. And the third parameter is minus pi halves. And the D parameter is -1. Now, we're going to find all the characteristics of a trigonometric function. We're going to find the amplitude, the period, the phase shift, the vertical translation, and then we're going to graph it. Remember, the period is the length it takes to complete a cycle, o sea, where I can find all the possible values of the function. So first, let's find the characteristic amplitude. So the amplitude, according to my data above, is just the absolute value of A. In this case, this is the absolute value of 3, and that is just 3. Now, my period is 2 times over the absolute value of B. That is my formula. And in this case, this is 2 times over 1/2. In other words, this is 2 pi over 1/2. And this is just a sandwich law that gives me that this is 4 pi. Okay, so that is my period. Now let's find the phase shift. The phase shift is the horizontal displacement, and that is found as 1 minus C over B. Minus C over B. So I have to substitute the value of B. So this is 1/2. So this is pi halves over 1/2, and this is just pi. And lastly, the vertical displacement or vertical shift. The vertical shift is just the D variable or the D constant, D parameter, and it is 1. From here, I can create my initial point from which I'm going to start graphing. So my initial point is pi, comma, -1. That is phase shift, comma, vertical shift. Okay, so that is where I'm going to start my graph. Okay, and I'm gonna mark this. So I'm gonna say this is pi. This is minus pi. So this is pi. This is 2 pi. 3 pi, 4 pi. Okay? So I'm going to start in pi. Pi, comma, -1. Here's my starting point. So here I'm gonna mark my period and my important points. That is the X-intercepts, the maxima, and the minima. So from here, I know that my period is 4 pi. So I have to mark the length in which I'm going to mark a full cycle of my function, and that is 4 pi, or 4 units, meaning that I can move either to the left or to the right. For convenience, I will always move to the right. So 4 pi means I'm going to land up here in 5 pi, no? I have 1 pi, 2 pi's, 3 pi's, 4 pi's. So here's the width in which all of my full cycle of a sine is going to land up in. So I'm going to divide this period in 4 parts. One in the middle, and one in the middle of each middle. From here, I'm just going to graph my important points, okay? So my x-intercepts, I know that are in the extremes and in the middle, meaning that my function has to touch these points. And I know that for sine, in the first fourth, it has its maximum, and in the third fourth, it has its minimum. So I just have to multiply that maximum value times my amplitude. That is, if I land here, 1 times 3, I'm going to move 1, 2, 3 upwards. And here, I'm going to move minus 1 times 3, that is minus 3. So I'm going to move 1, 2, 3. So my function is going to pass through all of these points. So it's going to look something like this. And this is obviously a pattern that repeats itself. So I could graph another 4 pi's here. 1, 2, 3, 4 pi's. And repeat my pattern all over again. 1, 2, 3, 4. And I know my function would have to do the exact same thing. It's going to pass through here, through here, through here. And here is going to pass through here. So the function is going to just copy the pattern all over again. Okay? Another example.